Hi, welcome to Algebra 2 Common Core. In lesson number 3, we're going to take a look at the unit circle, which is a very special circle that will help us to do some trigonometry in this chapter. A unit circle is just a circle that has its center at the origin and a radius of 1. We'll be referring to a diagram of the unit circle very soon in this lesson. Let's begin, though, by taking a look at some triangles that you should remember from geometry. The first triangle that we're going to see is called the 45-45-90 triangle. Now, see if you recall what the relationship between the sides are for the 45-45-90. We're going to start with our hypotenuse equal to 1. And if the hypotenuse is equal to 1 and I have a right triangle and both of the angles on the other two corners are 45 degrees, since they have the same measure, that tells me that the legs must have the same measure as well. This must be an isosceles triangle with two sides congruent. Now let's just remember really quick from geometry, if I've got a right triangle, I can of course use the Pythagorean theorem. So to find the sides of this right triangle, we're going to say x squared plus x squared is equal to 1 squared because 1 is the hypotenuse. That's going to give us 2x squared is equal to 1. When I divide both sides by 2, x squared would be equal to 1/2. Then I'm going to take the square root on both sides, so x is equal to the square root of 1/2. Now normally we would take the positive and negative square root, but because we're talking about sides of a triangle right now, we're just going to call them positive. Now we need to rationalize this radical, so that means that we're going to multiply the top and the bottom, numerator and denominator, by the square root of 2. So we're going to end up with x is equal to the square root of 2 in the numerator. In the denominator, radical 2 times radical 2 is radical 4, but the square root of 4 is just 2. That 2 does not go underneath the radical sign. So both sides on this right triangle are going to have a length of radical 2 over 2. Yes, we see that that length is an irrational number. Again, it's an isosceles triangle, so that's why the two legs are the same length. Hopefully you recall that relationship from your geometry class last year. Now, the other relationship that we're going to have to know, the other special right triangle, is called a 30-60-90 right triangle. Now, I'm not going to take the time to calculate how you got in geometry the sides. I'm just going to remind you of what those sides are equal to. What you did in geometry was use SOHCAHTOA, the ratio relationships for sine, cosine, and tangent. But the result was my hypotenuse, again, just like the 45-45-90, we're going to start with a basic hypotenuse of 1. The angle of 30 degrees is always across from the shortest side of the triangle, and that shortest side is always going to be half the hypotenuse. The bigger angle, the 60-degree angle, is going to be across from the next biggest side, even though the 1 is going to be the largest side. So therefore, this side is actually going to be radical 3 over 2. And again, if you plug those into the Pythagorean theorem, you will see that 1/2 squared plus radical 3 over 2 squared does equal 1 squared. So these two triangles are going to be really, really important for us throughout this whole trigonometry unit. So in example number 1, we're going to take a look at this diagram, which represents the unit circle. So again, just remember that if I have a unit circle, that means that the radius of this circle is equal to 1. I've also drawn the triangles to refer to, but you have them right above your unit circle diagram in your notes in the box. So I'm going to start with the quadrantal angles. So the quadrantal angles are the ones that form the quadrants. So for example, at 0 degrees. That means on my diagram, to get to that point on the circle, I'm going over the equivalence of the radius of the circle. The radius of the circle is 1, so that means that I'm going over 1 on the x-axis, but I'm not going up or down any on the y-axis. So the ordered pair at 0 degrees is 1, 0. At 90 degrees, this time I'm going from the origin up to this point, and I want to know the coordinates of that point. So I see that I'm going 0 on the x-axis, but I'm going up 1 on the y-axis. Continue on to the 180 degrees. I want the coordinates of this point. That means that from the origin I'm moving 1 to the left, but I'm not moving up or down any. So the coordinates at that point would be -1, 0. At 270 degrees, I'm starting at the origin and I'm going down 1 unit. So that means that I have gone 0 on the x-axis and -1 on the y-axis. I would finish it out by calling this one 360 degrees as well, but it would have exactly the same ordered pair, 1, 0. Now what I'd like to do is take a look at some of the angles that we have marked in the first quadrant. So for example, I'm going to start with one of the easier ones, the 45-degree angle. So to get to this ordered pair right here, what I want to do is notice that from the center along the hypotenuse of that triangle, that hypotenuse is equal to 1. Because I have a 45-degree angle right here, that tells me that I'm using this special right triangle of 45, 45, 90 to figure out the sides of the right triangle. So in this 45, 45, 90 triangle, I'm going to go over radical 2 over 2. But then from that point, I'm going to also go up radical 2 over 2. So the two lengths of sides that I've drawn in blue are the sides of that special right triangle where the x-coordinate is going to be radical 2 over 2, and I'm going to the right so it's positive. The y-coordinate is also going to be radical 2 over 2 because I've gone up that amount to get to that point. And again, just a reminder that this hypotenuse is equal to 1, but the hypotenuse doesn't matter in my ordered pairs. Now let's switch to the 30-degree angle in this triangle, or the triangle that's a 30 degree. So the 30-degree triangle would be right along this terminal side right here, bringing me to an angle of 30 degrees. That tells me that in my triangle, this part right here is 30. That tells me that this angle must be 60, and of course, here's my right angle. Now, referring to my 30, 60, 90, you'll see that this one is drawn a little bit differently because this time the 30 should be at the bottom. But I know that the hypotenuse is equal to 1, so that tells me that the side that's across from the 30 is equal to 1/2, and the side that's across from the 60 is equal to radical 3 over 2. Now be careful in the order that you plot this point. You want to go the horizontal distance first, radical 3 over 2, and then the vertical distance, 1/2. So the ordered pair at this spot right here is radical 3 over 2, 1/2. Now let's finish off quadrant number 1 by looking at the 60-degree angle. This is also going to use our special right triangle 30, 60, 90, but this time the angle that's at the origin would be 60 degrees. You'll notice that for my 60, I went over a little too far on that one, sorry about that. I'm going to go up here, and this is going to form my triangle. Hypotenuse is 1, the central angle over here is 60, and the angle at the top is 30. So remember, across from the 30 degrees, half the hypotenuse, so I'm going over 1/2 to get to that. That's the length of the base. The height is going to be the side across from the 60, so that's going to be radical 3 over 2. So what's important in this lesson is designating what the ordered pair is at each spot on my circle. Now I've done the first quadrant. I've done the quadrantal angles. I'm going to move to the next page to do the rest of the angles. So I'm going to replicate the answers that I have here on the next page and then start up with the other quadrants. Now in this diagram, I'm going to go around the circle and add in angles that are in the other quadrants other than the first quadrant. But I'm going to use the information that I had from the first quadrant. So let's begin with all of the angles whose reference angle will be 45 degrees. So in the first quadrant, that was this triangle right here, the one that we made in blue. And we saw that this central angle was 45 degrees, this angle was 45 degrees, and this one was a right angle. Now in the second quadrant, I want to find a matching triangle whose reference angle is also 45. So I'm looking for all the terminal sides that are 45 degrees away from the x-axis. So in the second quadrant, I'm referring to this triangle right here. So I'm going to go ahead and I'm going to draw in that triangle. It also has a reference angle of 45. So this would look like 45, 45, 90 right here. Now I know, of course, that this side of the triangle is radical 2 over 2. This side is radical 2 over 2, and of course the hypotenuse is 1. Now watch how this is going to work. To get to this ordered pair right here, to that point, I'm going to have to go along the x-axis in the negative direction. So I'm going to have to say that my x-coordinate is negative radical 2 over 2. But since my y-coordinate is still moving up, I'm going to say that the y-coordinate is positive radical 2 over 2, and that's what the ordered pair is at 135 degrees. Let's find the 45-degree angle in the third quadrant. So this time I'm going to say I want the terminal side that's 45 degrees away from the x-axis. So here's my 45, here's 45, and this is 90. I can already see that one of my sides is labeled. This side right here is radical 2 over 2. This side is also radical 2 over 2, and the hypotenuse is 1. Now think carefully about how I'm going to get to this point down here, the one that's marked 225 degrees. I'm going to go negative radical 2 over 2 because I'm going to the left to get to that point. But then I see that I'm also going to go down to get to that point, so the y-coordinate is also negative radical 2 over 2. Let's go to the fourth quadrant and find that 45-degree angle. So I see that I'm going to make this one right here so that this angle is 45, this angle is 45, and there's my right angle. Label your sides, so this is 1, this is radical 2 over 2, and this is radical 2 over 2. So at this point right here, at 315 degrees, I have gone radical 2 over 2 to the right, but then I've gone radical 2 over 2 down, so the y-coordinate will be negative. Now I'm going to erase all of my blue triangles so that I can move on to the red triangles. Now let's focus on the red triangles, the ones that have the central angle of 30 degrees, or the reference angle is going to be 30 degrees. That means that the terminal side is 30 degrees away from the positive x-axis. So we saw in the first quadrant that the coordinates were going to be radical 3 over 2, 1/2, because the side that's across from the 60 is going to be radical 3 over 2. The side that's across from the 30 is 1/2. And of course the hypotenuse is equal to 1. So let's look for the angle that would have a reference angle of 30 in the second quadrant, and that's going to be this one right here, the one that goes to 150 degrees. So again, it's a matching triangle. So I've got 30 degrees at the central angle, 60 degrees up here, across from the 30, 1/2, across from the 60, radical 3 over 2, hypotenuse is 1. So to get to this ordered pair right here at 150 degrees, I'm going to have to go radical 3 over 2 to the left. So the x-coordinate, negative radical 3 over 2. The y-coordinate, 1/2. Let's go to the third quadrant. Here's the 30-degree angle. I can tell that because this is 30 right here. This is 60, and here's my right angle. Across from the 30 is 1/2. Across from the 60, I've already labeled that, radical 3 over 2. So now to get to this ordered pair right here, I'm going to go radical 3 over 2 to the left, so the x-coordinate is negative, but then I'm going to go 1/2 down, so the y-coordinate is also negative. Finish it off with the fourth quadrant, so I want the 30-degree angle in the fourth quadrant. So that's going to make that triangle where I've got 30 in the center, 60 over here. Across from the 30, that side is 1/2. Across from the 60, I've got radical 3 over 2. Hypotenuse is 1. So to get to this ordered pair, we go along the x-axis first. So that's going to be a positive radical 3 over 2. But then we go down 1/2, so that'll be a negative 1/2. So you can see it kind of forms a bow tie when I make these triangles in each quadrant. So all of the red triangles are the ones that are the 30, 60, 90, where 30 is the reference angle and 30 is the angle that's touching the origin. Lastly, I'm going to go ahead and make the purple triangles. I'm going to see if I can erase the red ones in between here, so the purple ones are easier to see. Okay, the last triangle that we have to focus on in each quadrant is the one whose terminal side is going to be 60 degrees from the x-axis. So all the ones with reference angles of 60. In the first quadrant, you can see that I've made that in purple right here. So across from the 60-degree angle, that's going to be radical 3 over 2. Across from the 30-degree angle, that's going to be a 1/2, and the hypotenuse is 1. So going to the second quadrant, here is the terminal side, so that terminal side is 60 degrees away from the x-axis. So there's that side. This is 30. Across from the 30 is 1/2. Across from the 60 is radical 3 over 2. So the ordered pair at this spot right here, the 120 degrees, is going to be 1/2 to the left, so that'll be a negative 1/2, and radical 3 over 2 up, so that's giving me a positive radical 3 over 2. I noticed that 150 got erased here, so I'm going to go back and fill that in. That was negative radical 3 over 2, positive 1/2. Okay, let's go to the third quadrant and make my 60-degree triangle in the third quadrant. So I'm going along this side right here, ending at where it says 240 degrees. Here's my 60-degree angle up here. Here's my 30. So across from 30, I see that I've got the side of 1/2. Across from 60, this side is radical 3 over 2. So at 240 degrees, my ordered pair will be negative 1/2, negative radical 3 over 2. Lastly, let's go to the fourth quadrant. Again, this looks kind of like a bow tie or a butterfly. Here's my right angle. This angle right here is 60. This one is 30. So across from 60, that's radical 3 over 2. Across from 30 is 1/2. So the ordered pair at 300 degrees is positive 1/2, negative radical 3 over 2. I'm just going to look around my circle and make sure that I have all of my quadrantal angles labeled. So 0, 90, 180, 270, and this comes back to 360 as well. And then in each quadrant, I've got a 30-degree angle designated in red. And then I've got a 45-degree angle designated in blue. And I've got the 60-degree angles designated in purple. So that should help us to be able to identify what triangle I was using in each case. Now we're going to see in the next unit the significance of all of these ordered pairs. But for today, we're just going to answer some questions regarding this diagram. So for example number 2, it says, for each of the following angles drawn in standard position, give the coordinate pair from the unit circle. So really it's just a matter of looking at the circle that we've created and deciding what the ordered pair is. For some of these, we're going to have to rewrite the angle first so that we can find it on our unit circle. So for example, negative 120 degrees is not technically on my picture because I haven't drawn the negative angles. But I could say that this is coterminal with an angle of 240 degrees. So they would both end at the same spot and therefore have the same ordered pair. What was the ordered pair at 240 degrees? Well, let's see here, that came from our 60 degree reference angle. So that was negative 1/2 negative radical 3 over 2. And that's all I want you to do for this example. 495 means that we're past one circle. So we've gone around, completely around the circle once, 360 degrees. And we see that we've gone an additional 135 degrees. So the angle of 495 would be coterminal with an angle of 135. So they must have exactly the same ordered pair. Looking in the second quadrant, that ordered pair would be negative radical 2 over 2, radical 2 over 2. Let's go to C, pi over 3. I'm going to take a minute to convert from radians to degrees, so I'm going to multiply by 180 degrees over pi radians. The pi's cross cancel. 180 divided by 3 tells me that I'm looking at an angle of 60 degrees. So going to my circle at 60 degrees, the ordered pair is 1/2 radical 3 over 2. For the last one, 3 pi over 2 also needs to be converted to degrees. So I'm going to multiply by 180 degrees over pi radians. Go ahead and cross cancel the pi radians. Cross cancel the 2 with the 180 as well, and that's giving me 90 on top. So 3 times 90 tells me that my angle is 270 degrees. That's one of our quadrantal angles. So on the unit circle, the quadrantal angle of 270 degrees occurs at the ordered pair 0, -1. Now for right now, these ordered pairs might seem a little bit complicated. I tried to point out where each ordered pair came from, but we're going to be doing a lot more work in this unit on obtaining these ordered pairs and really getting to know this unit circle. Let's go to example number 3, where it says all of the points on the unit circle must satisfy the equation x squared plus y squared equals 1. Well, that of course is because I have a circle whose equation is centered at the origin with a radius of 1. And that would give me the equation x squared plus y squared equals 1. I also know that in any right triangle, the x just is formed by the base, the y is formed by the height, and the hypotenuse is 1 because I'm in the unit circle. So this also comes from the Pythagorean theorem. Now we want to take just one of the ordered pairs that we found on our unit circle. This ordered pair happened to come from, let's see, I believe that was our 150 degree angle. So this is occurring, that ordered pair was at 150 degrees. We want to show that this is actually an identity for this point. So I'm going to put negative radical 3 over 2 in for x and square it. I'm going to put 1/2 in for y and square it and show that this is going to equal 1. Now when I square negative radical 3, that's giving me positive radical 9. Radical 9 is just equal to 3. 2 squared is 4, plus 1/2 squared is 1/4, and of course that sum does equal 1. So we have shown that this equation is true for one of the points on our unit circle. Now this would of course be true for all the points on the unit circle. So let's try example number 4, where it says there are other points on the unit circle besides the 12 that we have designated. I am still going to use that equation, x squared plus y squared equals 1, but this time, if I've got an x coordinate equal to -5 over 13, let's find all of the possibilities for the y coordinate that would satisfy this equation. So for x, we're going to substitute -5/13. Let's square that. Plus y squared, we're trying to solve for the y, equals 1. So squaring this fraction, I'm getting 25 over 169 plus y squared equals 1. So, of course, I'm going to want to subtract 25 over 169 from both sides. So y squared is equal to 1 minus 25 over 169. I need a common denominator, so y squared would be equal to 169 over 169 minus 25 over 169. So y squared would be equal to 144 over 169. Let's square root both sides of the equation, but of course on the number side we're going to want to include positive or negative. So y would be equal to plus or minus, take the square root of the numerator and denominator, so I'm getting plus or minus 12 over 13. So when x is equal to negative 5/13, y can either be positive 12/13 or negative 12/13. So in class, we're going to work quite a bit more with this unit circle. Thanks very much for all your attention tonight, and have a great night.